Aloha and welcome to our video on seafloor spreading. In this video, we will identify mid-oceanic ridges and deep ocean trenches. We'll explain the process of seafloor spreading and subduction, and we'll explain the evidence for seafloor spreading, including paleomagnetism and magnetic reversals. Okay, so let's let our story begin here, where we're talking about deep ocean trenches. Prior to the 1940s, we believe that the oceans started off on one side and they kind of dipped down and formed the ocean bed here and kind of came up there. And we assumed that they were primarily flat at the bottom. Now, the way we used to measure depth is that you would have a boat sailing across, and as they got to a certain area, they would drop a rope and they'd measure how much rope was out, and that's how they could tell how deep it was. And that worked really well in close to shore, but once you got out beyond where the rope could reach, they just called it deep. Okay, and this was primarily to make sure that boats didn't run into things as they were sailing across the sea, and you had to worry about more when you got in close to shore. Now, in the 1940s, there was a new invention out. It was called sonar. And what sonar did is if we had a boat, it allowed them to shoot down a sound wave, and that would hit the bottom, and then it would bounce back. And by calculating the amount of time it took and the rate of the speed of the wave in the water, they could then measure how deep it was. And when these boats with sonar that was primarily developed to hunt submarines were coming back from Europe at the end of the war, what they found is at the bottom of the ocean, there were mountain ranges and there were deep spots, and it just looked a lot different from what they had expected. So by finding this information, it kind of gave us an idea that the oceans weren't what we thought. And by looking at that information, we can start to see different ideas coming around. So here we're looking at our trenches, and our trenches are these deep blue lines here. And our deepest part of the oceans are going to be like the Marianas Trench, which we'll see over in here. Okay. And these trenches were where we had deep, deep water going on. Now, conversely to the trenches, we had our ridges. And most of the ridges, perhaps the most famous one, is this Mid-Atlantic Ridge. And we can see that one that goes right down the Atlantic Ocean here. It actually splits Iceland and then kind of goes down the middle of the Atlantic. And that was something new to us. We had no idea that that was there. And we can see some of these other ridges as well. And what this gave us is an idea of what was causing this, what was going on, what at the bottom of the ocean is happening that's allowing this process to occur. So here's our nice little picture. It kind of shows us what's going on. We have our continental crust here, and then we have ocean over here. And you can see that we have two primary areas I want you to look at. We're going to have a trench, and the trench, you can see it's right over here. And then we also have what we're calling this ridge, this mid-ocean ridge here, and a rift valley here. And what we noticed is that as these two plates, and we notice a split in the plate here, that's what a rift valley is, and you can see this split over here. As these are moving away from each other, it's creating a hole or a gap, and we have magma coming up through that gap, and it's forming new ocean rock. So this is the formation of new crust is going on right here, right in the middle of this rift valley here. Now, if that's going on, what it's doing is it's causing the surface of the earth to get bigger. The crust of the earth is getting bigger. So the earth isn't expanding, it's about the same size. So that means somewhere we have to get rid of crust. And we noticed that that was happening at the trenches, where this oceanic crust here is being subducted underneath the continental crust. And as it gets forced down, it would melt, and we'll see what happens on in different places. But now we're losing crust over here. So over here is where we're losing crust, and over here is where we're gaining. So the surface of the earth is going to be about the same size. The crust of the earth is going to be about the same. The earth is not getting bigger, it's not getting smaller, but we can see where this process is happening. And by looking at these, then we looked for evidence to see, well, are the seafloors really spreading, or is this just kind of happening as it's going on? Okay, so once we discovered seafloor spreading was happening, then it was time to look for evidence so that we could prove that this was going on, that we knew this was the case. Now, one of the things that they found is we learned later on that you could just go down and look, and by sending down submersibles, we saw that there's evidence of volcanic material going on along these long mid-oceanic ridges, and that would show us that there's some kind of mountain building going on. It didn't show us that it was spreading, but it did show us that there was the activity going there that we would assume if there were spreading going on. We also developed ways to age rocks, and we found that the rocks located here, right by the Rift Valley, or where the mid-oceanic ridge was going, were much younger than the rocks we found further away. So by bringing up samples and testing those samples, we were able to see that these rocks here are younger, and then the rocks out here were going to be much older than the ones that were just being formed. Now, in this process, we discovered this paleomagnetism that you'll hear about. And what that tells us is we could look at the rocks, and some of our minerals, like hematite and magnetite, that are magnetic, lined up differently. And magnetite, which is actually magnetic, it would show us that the polarity of the Earth had switched over time. What that means is if we look at our Earth and we have our magnetic north and our magnetic south as it is now, that every couple of years, and not like a few years, but geologically a short period of time, like 10s, 20,000 years, we would notice that the Earth's magnetic poles would switch. And our north would be where the South Pole was, and our south will be where the North Pole was. And we noticed that down here in our rocks that we had these bands of normal polarity, reverse polarity, normal polarity, reverse polarity. And by looking at that and seeing that that pattern was mirrored on both sides of this ridge, kind of gave us the hint that we had this seafloor spreading going on. Now, seafloor spreading kind of gave us an idea that Wegener's hypothesis of continental drift might have had a little bit more to it than we gave it initial credit. And when we take both of these together, we came up with a brand new theory, and we'll talk about that one in the next video. Good luck on your lessons and your quizzes this time, and we will see you in that next video.